Hello there, welcome to section 3.2. And in this section, we're going to be looking at the derivative as a function. So to recap, in the previous section, we learned that f prime of x naught, that's the derivative of a function f at the point x equals x naught. This tells us the slope of the tangent line to f at that specific point. The key word there being specific point. Okay, so in section 3.1, we're calculating derivatives and we would get just a value for the slope of the tangent line at a particular location. But the truth is we can actually look at the derivative in a more general sense than that, at more than just one specific point. So here we're going to look at the derivative of f of x in a more general way. And here we say this is going to be f prime of x. Notice how that's not, that is not x naught anymore. Not x sub 0. It's just general x. So f prime of x is defined as the limit as h approaches 0, f of x plus h minus f of x over h. Okay, so this definition should look familiar. It's the same one that we saw in section 3.1, just now instead of using a specific point x equals x naught, we're just using the general variable x in these three locations there. Everything else exactly the same. So the trick here is instead of putting a number in those locations, you're just going to leave the variable x. Okay, so when we do that, this is going to give us a more general expression. This gives us the slope of the tangent line at any point. Okay, since we didn't plug in a specific point value to start with this definition, it's going to give us a general expression and then you can just plug in the point that you want. So you can do any point there and then you would just plug in the x value that you want. Okay, the x value that you want afterwards. So you would do the calculation and then you would plug in x instead of the other way around. Now that idea of, plugging an x value into something is what we do with functions. And truth is that this is a new function that we are creating with this general definition of the derivative. So this is a new function created from the original f of x. Okay, so what that says is when you're taking these general derivatives, it is not necessarily going to be a constant value like we've seen before. This is a new function, so it can still contain a variable. Okay, contain the variable x. All right, and that is a key difference here. So you can do this calculation, compute the derivative. It's going to be the formula for a new function, can still contain the variable x. And then if you want to find the slope of the tangent line at any point, you would plug in the x value of your choice afterwards. All right, so in the next video, we'll see what this looks like.